Hello, this video will help you with problem number 59 in chapter 7. It's actually a callback to the kinematics unit when you're doing the center of mass. With this center of mass problem, you're looking at a mallet. So they give you the diagram already, but I'm going to go ahead and redraw it. So we have a mallet, and they have the handle going to the left. Let's see, mallet head's about that big. Oops. Yeah, I can do better than that. I guess that's close enough. So the whole point of the problem is to figure out the center of mass for the entire mallet. Okay. And they tell you that the distance for the handle into the base plate where it connects, I'm actually going to change that to blue. So from here to here is 24 centimeters. From here to there. They also tell you that the diameter of the mallet head is 8 centimeters. Now for the point of sig figs, they tell you it's 24.0 and 8.00, but I won't fit that here, so I'm just going to write 8. But when we're doing the sig figs for this problem, it will be 3 sig figs. Okay, so they want you to find the center of mass from the handle, if I remember correctly. Yeah, from the bottom of the handle. Yeah, so we're going to draw a dotted line here at the bottom of the handle, and we need to measure from that reference point. So basically this is X initial, this is our reference, whereas it's 0 meters. And we have basically two different pieces that are uniform. We have the handle that's uniform, and we have the mallet head that's uniform, and we need to figure out the center of mass for the whole object. So to do that, first, before we can identify what we need to know, you need to make sure you can remember the equation. It's the equation that you're expected to memorize, so if you haven't done so, you need to do so. X, C, M, so position is X, obviously, position of the center of mass equals the mass of one part times the center of mass for that one part plus the mass of any other part. So in this case we only have two parts, so we're going to have mass 2 times the center of mass for that part. And normally this equation would keep on going, but in this case we only have two pieces, so we just stop there. All divided by the sum of the masses, so m1 plus m2. Again, if they had another piece, I'm going to show that in green. If they had like another piece here that I'm doing in green there, then we'd have a third mass times a third position, and we'd be dividing it by adding the third mass on the bottom there. That's if we had the green piece. Okay, we don't have that in this case, but I want to make sure you guys are realizing that this equation can continue going on. It doesn't have to stop with 2. Okay, so we aren't dealing with the green, so I'm going to go ahead and erase that so it doesn't get in your way for understanding it. We need to be able to identify the masses, and they do give you the masses for the individual pieces. They tell you the handle has a mass of 0.5 kilograms and the head has a mass of 2 kilograms. So I'm just going to write that in here. I'm going to write m1 equals 0.5 kilograms. And then in the mallet, I'm going to write m2 equals 2 kilograms. Once you're done with that, you need to identify where x1 and x2 are located. x1 is the position of the center of that handle. If it's uniformly distributed, it should be directly in the middle of the handle. So we're trying to find x 1 here. If it's in the middle of that handle and the whole handle is 24 centimeters from the base of the handle, then we know x1 will be 12 centimeters, or I can write 0.12 meters. You will convert because you're supposed to. Yes, the equation will work if you don't convert, but you should always be converting to standard units just in case you're doing an equation that requires a constant. So it's 0.12 meters. Now we need to find out the center of mass for this mallet part. You cannot just divide the 8 by 4 and say its position is 0.04 meters, because we have to measure relative to this dotted line right here. Okay, so the one I'm highlighting in yellow, we have to measure relative to that. So we know that the center of the mallet, okay, is 4 centimeters from where the handle ends, and that the entire handle is 24 centimeters. So basically we have to add 24 centimeters plus 4 centimeters, you get 28 centimeters. So you get 0.28 meters. Okay, now we have everything we need to know, so we can just go ahead and plug it into the equation. We have x cm equals m1, which was 0.5 kilograms, times x1, which was, oh, okay, I do realize I missed one thing. We do still need to just specify which way is positive, so technically to the right needs to be shown that it's positive, so that this is a positive position here and a positive position there. So we have a positive positive 0.12 meters. The positive is key in order to know which way the center mass is going to go relative to your reference. In this case, it's obvious it has to go to the right because there's no mass to the left of our reference, but that does help to argue when our answer is reasonable. So M2 was 2 kilograms. We have to multiply that by a positive 0.28 meters, and all of that will be divided. Nah, I didn't mean to cross into that. Let's try that again. All of that will be divided by 0.5 kilograms plus 2 kilograms. So just basically plug it in the calculator at this point. You should get a value of positive 0.248 meters. That's the correct answer with significant figures. There's 3 significant figures. The mass they gave you was 2.00 kilograms and 0.500 kilograms. The diameter was 8.00 centimeters and 0.240 meters. Sorry, I don't know why I was blanking on that one. So they definitely given you 3 sig figs there. It's funny, I just realized they give you the centimeters on the drawing, but they actually do give it to you in meters in the actual question. So you wouldn't even need to have trouble converting that. They tell it to you right there. So that's all there is. You'd say the center of mass is a positive 0.248 meters in the positive direction. I would say to the right of the base of the handle. So basically it would be in here slightly, so 24 would be about here. Okay, maybe even less than that. Okay, that seems perfectly reasonable considering the amount of mass that's in the mallet. We only have half a kilogram outside the mallet head, so you can't move the center of mass that far away from where the mallet center used to be, which again would have been originally in here where I'm doing the green. That's where the mallet head would have been without the handle, and because of the handle it moved there. Okay, which does make sense. Okay, that's all for that.